Hello everyone, my name is Roy Jafari and in this video I'm going to teach you about clusterings. Before we start here, if you don't know what is classification or haven't watched my previous video, make sure to watch that first. The name of that video is A Taste for Classification. So clusterings are another very useful data mining task that you can basically use to summarize a multi-dimensional data set. By multi-dimensionals, I mean basically your data has more than 2 or 3 columns, and all of these columns are adding meaningful dimensions to your data set or to the populations of your data objects. When you have such a data set, for you to understand what's really happening in your population in the data set, you need some tools that can handle more than 1 or 2 or 3 dimensions, and that's clustering. So first, in this video, I'm going to show you what really clustering algorithms are in very simple terms, and I'm going to use classification to sort of distinguish between the two and help you understand what clusterings are. Then once you understand that, we use clustering to do some market analysis of stock market and see if we can use clustering to help us find the next best stock I need to invest my money in. Okay, let's get to it. So when we do classification algorithms, the classification algorithm has a specific goal. The specific goal of classification algorithm is to find a relationship between the independent attributes in your data set and the dependent attribute or the label in your data set. And once you find those relationships that help to find that connection, so you can run the new data object by the algorithms that has learned from the data to see what's going to be the label of the new object. But with clustering, we don't have a label in our data. There is no task that we want to really see if there is a connection between some independent attributes with the dependent attributes. So if you don't have a goal to classify or predict your data, then probably the data mining task that you need is clustering. So with clustering, what you really are trying to do is to get into your data and see if the data can be grouped in different groups that are meaningful. So basically you want to group your data objects based on the similarity that they have under the attributes. So here we have A1, A2, A3 all the way to AM attributes. Each of these attributes offer variation into the space of these populations of data objects. So based on all of these variations across these attributes, you want to see if there is a meaningful grouping among these data objects. And by finding that grouping, you can basically summarize what's happening in your data and see if those patterns can help you make better decisions. So now that we understood clustering, what really is in simple terms, so now let's go to Jupyter Notebook and take a look at an example and see if we can use clustering to see what's happening in the market, the stock market. Okay, let's get to it. Okay, now that we have a better understanding of what are clustering algorithms, now let's take a look at this example. In this example, I want to see what's happening in the stock market for these 58 popular stocks. So these are the popular stocks on the Robinhood app. So I want to see if I can find some meaningful trends in the market using clustering algorithm. So first thing I have done here, I have created a symbol df, which is basically my database of the name of these symbols. Later in the code I will use this. And now what I have done, I have used Yahoo Finance API and another API, third API, it's FinHub, to sort of collect online data from the stock market. So these data that I'm showing to you in this video has meaning for just right now that I'm recording this video. So I'm collecting the online data of the real-time data of the market, and I'm using clustering to see what's happening in the market. You saw it took a little bit for this data set to be loaded. So I collected yesterday change, last week change, last month change, and the rating from these APIs, and collected and also calculated. So these are all calculated, sort of like attributes. So they calculated from the data I got from these APIs. And now that you see there are 4 attributes that we are going to be using to do the clustering algorithm, you can see if it was 2 attributes here, I would be only doing a scatter plot, right? But now it's sort of like becoming a little bit overwhelming for our human comprehension. So that's why we tend to clustering algorithm to help us see if there is meaningful grouping among the data object population, in this case here, among the stocks based on these 4 attributes. So one of the first things that we need to do when we work with any data for any analytics, really, clustering, classification, prediction, is to get to know the data. So there are a couple of good functions that we can use from Pandas. We can use the describe function to see the minimum, maximum, mean, standard deviations of all of these attributes, and also run the visualizations, histogram, box plot, bar charts of these attributes. Since all of these are numerical attributes, we have done the histogram and the box plots for all of these 4 attributes to see what type of values these have. One of the things that we see here is that the scale of these numbers, these attributes are different. Why last month changed from -30 to 37, rating is only between 0 to 2.1. So if we were to do clustering on these, quote unquote raw data, as in we haven't processed them for clustering yet, last month's change would become more important because it has a larger scale of numbers. That's why we normalize our data set. And by that I mean I change the data or re-represent the data in a way that all of the attributes are falling between the same range. And here I have chosen between -1 and 1. And once I have this pre-processed data, now I can take advantage of the clustering algorithm. In this video, I have used K-means, which is perhaps the most applied, most well-known clustering algorithm, and the simplest one. One thing you want to know about clustering and K-means clustering algorithm is that while it is a really good algorithm, it's still a random algorithm, and every time you run it, you might get a different output, with outputs being similar but with very little things being different about them. And it's because of that we have to always make sure that we always pick the best clustering. So here I'm going to run 100 different K-means on this data set and use a measure called silhouette score to see which one is the best one. So I'm going to run this, and this is gonna take a little bit because it's like 100 times of running this algorithm on this data set. And since this data set is not very large, it did last a few seconds, but it wasn't that much anyway. So instead of just leaving my faith to destiny by just running one time this algorithm, I have run it 100 times, and now I can see there is most of the time it is reaching a consistent cluster, but there are times that it gets even better. So I'm gonna choose that sort of output that gives the best silhouette score, and to do that I have grab that one using the np.argmax, which sort of gives me where is the index of the maximum in this 100 array or data frame here, and sort of like use that as sort of like the membership for my clustering. One thing that you want to pay attention here, that I used number 4, the 4 number of clusters. So this is something you have to learn. How do we go about finding how many clusters we want or our data have? So I'm just going to gloss over that in this specific video, but that's something, yeah, you will have to learn eventually. So these are all our, cluster membership. So I'm going to add that into my data frame. So now I have a data frame that the data frame also have that cluster attribute to it. So now that I have this clustering done, I want to see the patterns that have caused this clustering. So this is sort of like reverse engineering. I use an algorithm that use all these dimensions to sort of find the patterns. Now I see those patterns, and that helps me to understand what's happening in my data. So to do this, I am doing something called centroid analysis. Each of these clusters have some members. So I calculate the average of I gather all of these members together at once and then calculate their average. And this is their centroid. So if you do that, this is going to be the centroid of your cluster. So you can see yesterday change for cluster 0, 1, 2, and 3 are different, and so on and so forth. So this is good with the numbers, but we can even do better because it's programming. We can do something like this that helps us to sort of visually see this. So now I can see, for example, cluster 1 cluster 0 has a very low rating, and so on and so forth. And I have done even further. I have reproduced this sort of like heat map for each of my clusters. So here I have sorted the attribute based on the values on centroid cluster 0. Then I have sorted the attribute based on cluster 1, and then I have sorted the attribute based on cluster 2, and then based on cluster 3. So now I can look at these attribute, these visuals, to see what's happening between each of my clusters. So I can see in cluster 0 the rating is very low, so is the performance, right? So the rating is low and the performance is also low. Last week performance was low, last month performance was low, and also yesterday change was low. In cluster 1 the rating is high and the performance is not high or as low as cluster 1, so lowish. For cluster 2 the rating is high and the performance is better than the other clusters. So this is an interesting cluster. And then for cluster 3 we have the rating is not very high or low. I mean, it's sort of towards low, but the performance is mixed. The last month performance has been high, but the performance of last weekend yesterday hasn't been that high. So using these, I can go ahead and sort of like give a name to these clusters. So let's do that together. So I call cluster names and I'll create a list with their names. So the cluster 1 was let's call it low rate, low performance, right? Performance. Cluster 1, let's call it high rate. Yeah, I have to change this too, right? High rate, medium performance. Cluster 2, it's high rate, high performance. and eventually cluster 3 is mixed rate and performance. All right. So now let's go ahead and sort of see these stocks under each cluster. Now that we sort of like give each cluster an identity. So now I see the mixed rate and performance is these clusters. We have American Airlines, Boeing, Twitter, United Airlines, Spirit Airlines, Royal Caribbean, Prospect Capital. So these are all the mixed performance. And then we have high rate, high performance is, these ones. We have Apple, Amazon, Disney, I don't know, Facebook, so on and so forth, Google, Microsoft. And then we have high rate, medium performance. So these are the ones that have sort of high rates but medium performance. And we also have low rate and low performance. We can see, for example, what's happening in our stock market analysis, and perhaps sort of like see where we would want to sort of on which of these groups we would want to sort of like enter the market with